So this is the second video, continuation of the first video. So in that we saw about the structure of the functional group that will continue here. Okay. So we saw that the three hybridized p orbitals of this carbon is involved in this sigma bonding as like this. One with carbon, other with another carbon, and one with oxygen. In case of aldehydes, it will be bonding with hydrogen, and in case of ketone it will be with 2 carbon. Okay, so these all will be linear overlap, so it forms a sigma bond, but it will be another one orbital, another one electron will be there, which is unhybrid, which is referred as unhybridized p orbital. So it will be present in the plane, in the above and the below of the plane. Okay, can you imagine this? So only I have drawn a plane and I have written here, so it will be at the top and bottom of the plane. So it overlaps in a it laterally, that is in the sideways it overlaps, and it forms, since the overlap is sideways, you say it as a pi bond. If the overlap is linear, you say it as sigma bond. Okay, that you have to remember. Since here the overlap is in the lateral, you say it as a pi bond. Okay, so now how does it appear? So it bonds and it forms a cloud like this. It is called as, see in your book they have given here, it is as a pi cloud. So this is nothing but the pi cloud. It forms a pi cloud. Okay, so what happens is that it forms a pi cloud, and this pi cloud is makes this carbonyl group more active. Okay, ma'am. So now it forms a stabilized, so it forms a resonance structure. How does it comes? So here the carbon is less electronegative when compared to oxygen. So here the bond is between carbon and oxygen, right? So here the oxygen is more electronegative when compared to carbon. Okay, so now what happens? Since it is more electronegative, it tries to pull the bond towards itself. It will pull the bond towards itself. As it is pulling, it attains a positive charge, and here the bond changes into it. Since it is gaining electrons, it is changed into minus. So I have explained already in your class how does an atom acquires a positive and the negative charge. Since it is losing the electron, it gains positive charge. Since it is gaining the electron, it acquires a negative charge. Okay, if both the positive and negative ions or charge is present in a same molecule, you say it as a polar molecule. Okay, since now here carbonyl group, since oxygen is more electronegative when compared to carbon, here what happens? This carbon attains a positive charge and the oxygen attains a negative charge. So both will be present in the same molecule, so you say it as a polar. So here the bond is polar bond. Okay, so this polarization effect, this positive and negative charge present in this group makes this group more active. So they are more reactive. They are very eager to involve in the reaction, so they eagerly involve in reaction and produce the products. So this is the reason, the polar bond, this is the reason for the more reactivity of this carbonyl groups. Either it may be an aldehyde or ketone, it is more reactive due to the presence of this polar bond only. Understood, students? I hope you understood. The first point you have to remember is it is sp2 hybridized. The carbon which is present in this carbonyl group is sp2 hybridized, and the oxygen bond is similar to that of the carbon-carbon double bond seen in alkenes, and it has 3 sigma bonds. How do they form sigma bonds? Means by the linear overlap. See, in case of aldehydes, the linear overlap is between carbon and carbon, and here carbon and hydrogen for aldehydes, and another it was oxygen. So this carbon oxygen bond is same for aldehydes and ketones, and this carbon carbon bond is also same for aldehydes and ketones, but here only the bond differs. In case of aldehyde, you say carbon and hydrogen. In case of ketone, you say carbon and carbon. So all will be sigma bond only, and the angle is 120 degrees. So this is very important, you have to mention the angle. What is the angle? Is 120 degree. Okay, so three sigma bonds are formed. three hybridized orbitals forms the sigma bond, and there will be one unhybridized p orbital which is present in the carbon. So it occupies the up and the above, top and the bottom of the plane. So that I have explained it here. See, it occupies the top and the bottom of the plane. Since similarly the oxygen also has a unhybridized p orbital, so it also occupies the top and the bottom of the plane. So there will be a lateral overlap, sorry, there will be a sideways or lateral overlap between these two p orbitals, and this, since it is a lateral overlap, you refer it as pi. Here, since it is a linear overlap, you say it as sigma bond. So these two pi will overlap and it forms a pi cloud. So the pi orbitals will be present as a thick pi cloud, and the above and the below of the plane, they will be present as a thick pi cloud at the above and the below of the plane. Okay, that you have to remember. Then one more thing you have to remember is that it is that since it is a planar molecule, it lies in along the plane, the shape of it is a trigonal planar. Okay, so now we are going to see how they are more active. They are more active due to the polar bond. So how they form the polar bond? The resonance, this carbon, is less electronegative when compared to oxygen. This oxygen is more electronegative, so it tries to pull the bond towards itself. So as a result, since it is giving the electron bond, it gains a positive charge. Since it is attaining the bond, it is gaining electrons, it occurs a negative charge. So since a positive and a negative charge is present on the same molecule, you say it as a polar molecule, and the bond here is a polar bond. Due to this polar bond only, due to this polarization, the aldehydes and ketones are more reactive, are highly reactive when compared to other functional groups. Understood? Hope you understood. If you are not able to understand, you can ask me. Okay, students, so now we'll see about the next topic, that is preparation of preparation of aldehydes and ketones. So this is also an important question, you have to listen carefully. Okay, so first is the preparation of aldehydes and ketones by the oxidation and catalytic dehydrogenation of alcohols. So you have already learnt that this primary alcohol gives aldehydes, and so I have said you right, primary alcohols gives aldehydes and secondary alcohols give ketones. This we have studied in the hydroxy group, right? So what is the reagent used? Is acidified Na2Cr2O7. So I'll write it and explain. So what you have to do is,